We're going to talk about Simularity's predictive archetypes, specifically for time series data. By definition, an archetype is a model after which other things are patterned, and so these are actually predictive models. And our predictive archetypes are a weighted list of features that describe a group of items. Now, a group of items may be events that you're trying to model or predict. It's generated by looking for features that are highly correlated with the specified group. And you can then use this to score or estimate the probability that other items might belong to the group. Using a predictive archetype is easy. You define the group you want to model. You view the characteristics that distinguish the group, and you can score others based on the matching characteristics they have. You don't need to know which questions to ask. It looks for the most correlated features in all of your data. And you get more than predictions, you get explanations. You get to see why we predict that an item should belong to the group that you're trying to model. So event predictive archetypes are a special type of predictive archetypes. Events, in terms of time series data, are things that we want to be able to predict. So event predictive archetypes consist of a set of event signatures. An event signature represents the different ways that the event can happen. So for example, I'm going to show you the hard drive failure event predictive archetype, and it might be composed of event signatures that represent all the ways that a hard drive can fail, such as a power supply failure, a bad sector, head failure. One can imagine that the sensor signatures are going to be different for each of these different types of failures, but you'd like to be able to predict all of them accurately. Each of these different ways that the event can happen will have a distinctive pattern of sensor readings that are predictive of the event. Which sensor readings are predictive and what their values are may be very different between event signatures, such as those for a power supply failure versus those for a head failure. So an event signature represents a distinct pattern of sensor readings that occur prior to an event. An event signature shows the users the reading from the relevant sensors prior to the event. You may have many sensors, and most of those readings may not be relevant to predicting the event. Which sensors are relevant in predicting the event and the degree of their relevance? And it includes the rate ratios chart for the sensors that are relevant for this particular event signature to indicate the degree of relevance. And so here's an example of what an event signature looks like. Here you can see that for this event that we predict will happen in 1 hour, the 5 sensors out of the 53 that we think are most predictive of the event here are servo 1, servo 5, fly height 2, fly height 6, and fly height 1. And here we indicate the relative significance of each of those. And so we think that this pattern of behavior on servo 1 is the most predictive sensor pattern of this particular event. You can use time series predictive archetypes for predictive maintenance. And here's an example that we created. The goal is to develop a predictive archetype for hard drive failures based on historic data. So we've got 53 different sensors per hard drive. We've got historic data of readings taken every 2 hours for 12 days prior to a failure. And we've got training data of 300 hard drives. About half failed and half of them are operating normally. So what we can then do is take the predictive archetypes that we generated from this training data and use those to monitor live devices so that we can monitor all sensors in real time for indicators of impending failure. We can score each drive to indicate its likelihood of failure. We can predict the hours to failure based on the sensor readings that we're seeing. We can show which sensor readings lead to the failure prediction, and then classify the types of failures based on which event signature is matching the behavior exhibited by the drive. So here we have a drive status dashboard, and we are monitoring all of our drives, and the summary status is up here for all of our drives. And the score here represents the likelihood of failure. And you'll notice that we also have a time to event that represents the predicted hours until failure. What we did was click on one of these failed drives up here that are in the critical state with only a 1 hour time to event, and this here is the event signature. So here is an example of the drive status dashboard where you can look at all the other sensor readings. There's 53 sensors, and if you're looking at exploring a particular drive, you can bring up widgets to look at any of the additional sensor readings over time. Here's two different event signatures for failed drives. Now you'll notice that these two drives have very different event signatures. In the case of the top one, servo 1 is the most important sensor, and the pattern looks like this. In this case down on the bottom drive, servo 5 is the most important sensor, and the pattern is very different. For example, servo 5 is important up in the top one, but you see that the shape of the sensor readings prior to the failure are very different. But in this case, both of these drives failed, and we were accurately able to predict the event signature and the failure for both of these drives, even though what the sensor readings look like prior to the failure were very different for each of those drives. You can also use event series predictive archetypes for anomaly detection. Here's an example of an anomaly detection demo that we did. And here is an anomaly that we highlighted. And what we did is develop event signatures for all the normal patterns. In this case, we're measuring response times. And we also have an event signature for an abnormal pattern. And here we indicate the predictive strength of this anomaly event signature. Our predictive archetypes have a number of advantages. First, they can be created without writing any code. All of these can be created from a point-and-click user interface. They're explainable. It's easy to see which features describe the target group. If we're trying to convince somebody to take an action, like go and replace a power supply on a drive, you want to be able to explain why you think that power supply needs to be replaced. It can include data from a variety of sources. As you saw, there was 53 sensors in the hard drive predictor that we've got. These could be sensors of any type or any type of readings. In the anomaly detection, you saw it was response time readings that we were looking at. The predictive archetypes can be explored on the fly to facilitate discovery or be used to create alerts. Again, you can dig into the different sensor readings and look at the signatures for each of the drives, whether they're healthy or not. And they can be used for real-time scoring. Additionally, they can learn on the fly. If, for example, what's normal changes over time, then your anomaly detection can recognize that and change with it if you want. And time series predictive archetypes are perfectly suited for Internet of Things applications because most of those are sensors that are creating this time series data, which is a set of sensor readings over time. Thank you.